Welcome back. And in the last video, we checked out how to tune a model's hyperparameters by hand. And we figured out by the end of it, once we'd written some code, once we've split our data into train, validation, and test sets manually, we created an evaluation function. Yeah, and at the end, we figured out, tuning a model by hand, that sounds like a lot of work. And you're right, it would be if we went through and tried a whole bunch of different hyperparameters. But luckily, the developers of scikit-learn have also come across this problem and have created randomized search CV, which stands for randomized search cross-validation. Let's see how we'll tune hyperparameters, so aka adjust the settings on our models to make better predictions, or hopefully make better predictions, using randomized search CV. So let's go here. We'll create another heading. This can be 5.2. So hyperparameter tuning with randomized search CV. Beautiful. First thing we'll do is we'll import it. So from sklearn.model_selection, import randomized. Now we might be able to press tab here. Randomized search CV. Beautiful. Let's see an example of how we'll use it before we check out the docstring. So what we'll do is we'll create a grid of hyperparameters. And by grid, I mean dictionary. And I've typed grod here. A dictionary of hyperparameters we'd like to adjust. So if we come back up here, these are the hyperparameters we're going to adjust. So what we're going to do is create a dictionary with the hyperparameters we'd like to adjust as the keys, and then the values we'd like to try as the values of the dictionary. So let's do that. So n estimators, that's a key. We're going to pass it a list. So 100, 200, 500, 1000, and 1200. Beautiful. Now, if you're wondering, Daniel, where are you getting these values? Well, remember, as always, with any model or estimator in scikit-learn, there's extensive documentation on it, which tells you some of the settings that you can change on the model. So what I've done is I've read through here, read through the examples, done some research, and found different values for the hyperparameters we can try. So we go here, none, 5, 10. So if it looks like I'm just throwing out values here, trust me, they're not just sort of thrown out values. They are based upon some research and some experience. And don't worry, you won't begin with that. No one begins with that. It takes a little bit of practice to go through it. That's why we're having a look hands-on at all these different functions that we can use to improve our models. Wonderful. And then we'll do 2 more, which is min samples split. 2, 4, 6, comma here. Min samples leaf. And let's see how we'd implement randomized search CV. So we'll set up a random seed. We'll split into X and Y. So we want heart disease, shuffled actually, because that's what we've used before. Dot drop, oh actually we need to make X here. Dot drop, target, axis equals 1, and we'll make Y here. So heart disease, shuffled, target. Beautiful. And we're going to go split into train and test sets. You might be wondering, why are we only using train and test here? We've just created a validation set. Now, we'll get to that. Y train, Y test, train test split, X, Y, and we'll use a normal split here. So test size equals 0.2. Wonderful. And then we're going to instantiate random forest classifier. CLF equals random forest classifier. And jobs equals, now we could do -1 here, but at the moment -1 is broken for me. Now that'll make sense in a second, But njobs stands for how much of your computer processor are you going to dedicate towards this machine learning model. And -1 means all of it. So by default, njobs is 1. Or actually, what is the default njobs? Let's go here. njobs equals none. Okay, so we'll set it as none. Actually, I'll just set it as 1. So different values you pass to njobs will dictate how much of your computer processor that you want to dedicate towards a machine learning model. And now, once we've got a classifier instantiated, we'll set up randomized search CV. So we're going to pass it. We're going to call it RSCLF. So what that's going to do is it's just appending RS to it for randomized search. And now, randomized search CV, the first parameter it takes is estimator equals CLF. So we're passing it this random forest classifier we've instantiated. Param distribution is the next one. We're going to pass it our grid. So this is grid up here. And the next thing is we're going to define an iter. So equals 10. And this is the number of models to try. We'll do 5-fold cross-validation. And then we'll set verbosity verbose equals 2. Whoa. This is some code we haven't seen before. So what is happening when we run randomized search CV? We look at the doc string, press Shift Tab in here. Oh, it's because we haven't imported. That's all right. We'll press Shift Tab here now. So what's the doc string here? Randomized search on hyperparameters. Randomized search CV implements a fit and a score method. It also implements predict prober, decision function, transform and inverse transform if they implemented in the estimator used. So randomized search on hyperparameters. That can sound a little bit confusing. What does it mean by randomized search? So that's in the name, randomized search CV. CV is for cross-validation, which is where you might recognize this parameter, CV equals 5. So that means we're using 5-fold cross-validation. So 5-fold cross-validation. This is why we don't necessarily have to create a validation set here. So what randomized search CV will do is it'll take our classifier and it'll take a param distributions grid, which is this, and it's going to search over this grid for 10 different times, different combinations of these parameters at random. So for example, on its first iteration, so because it's doing n iter equals 10, it's going to do this 10 times. On its first iteration, it might try a model with 10 estimators, a max depth of none, max features set to auto, min samples split set to 2, min samples leaf set to 1. And then on the next iteration, so iteration 2 out of 10, it might try 1,000 estimators, 30 as the max depth, auto as the max features, 4 is the min sample split, and then 4 is the min samples leaf. Then it's going to keep going that up to 10. Now we could set this to 100, to 1,000. I don't think there's even 1,000 combinations in here. If you went through, you could go 6 times 5, that's 30, times 2, that's 60, times 3, that's 180, times 3, that's 460 odd. And the math may be a little bit off there, but you can get the point, right? If you went through all of these and tried to combine them in every single combination, that's going to be a lot of different models. So let's see this in action. So once we've set it up, instantiated randomized search CV, we'll go here, fit the randomized search CV version of CLF. On rs clf.fit xtrain.ytrain. Now the reason we only have to fit it xtrain and ytrain is because the CV in randomized search CV stands for cross-validation. So that is what it's going to do. It's going to automatically make our validation sets for us, which is a beautiful thing. So if we come back to our diagram, it's going to take our data, and then it's going to try different hyperparameters cross-validated on different hyperparameter settings. So that's what it's going to return. It's going to figure out which combination of these hyperparameters is the best, up to 10 different models. And again, we could increase this if we wanted to try more combinations. So let's see it in action. So this is where we've set the verbose to 2. It's going to output and tell us what's going on. So fitting 5 folds for each of 10 candidates, totaling 50 fits, aka it's trying 10 iterations of different combinations of parameters in this grid and splitting each combination 5 times because CV equals 5, totaling 50 fits on the data. So it's going to run this fit function 50 different times using different hyperparameters on different splits of the data. So we can see here, the first split it's trying is n estimators equals 1200, because this is one of our hyperparameters up here. And remember, each split, each iteration, it's going to pick combinations of these at random. It's also set min sample split to 6 here, min samples leave to 2, max features to square root, and max depth to 5. Okay. And then if we were to scroll through here, we can see all of the different combinations it's tried. So let's pick one at random. This one here. So this combination is trying n estimators equals 200, min samples split equals 6, min samples leaf equals 2, max features equals square root, and max depth equals none. And then it's going to keep going until it's finished. It's going to give us a warning here. So let's see. Once it's finished, what we'll be able to do is call best params on it. So if we go rs_clf.bestparams, and this is going to show us the combination of hyperparameters, which combination of these got the best results. Wonderful. So where n estimators equals 200, min samples split equals 6, min samples leaf equals 2, max features equals square root, and max depth equals none, they were the best cross-validated results across 10 different models. And now, when we call predict on our randomized search classifier, by default, it's going to use these parameters. So instead of finding these by hand, randomized search CV has found them for us. So let's do it. Let's make predictions with the best hyperparameters. So what we might do, rs_ypreds equals rsclf.predict. And we could use the validation set here, but in our case, we're going to use the test set. And then we'll go evaluate the predictions. rs metrics equals evaluate y test rs_ypreds. Oh, our function is supposed to be evaluate preds. There we go. Wonderful. So if we come back up here, did we see an improvement here? No, we didn't. And so this is the sort of where the experimentation comes in hyperparameter tuning. You won't always find an improvement after running something like this. Maybe we could run it for longer and try 50 different combinations. And after it's tried 50 different combinations, it will find some parameters which end up being better than our manually tuned result. But what I hope you're starting to see is that using randomized search CV, rather than running through all these different settings by hand, it gives us a way to codify or functionize the tuning of hyperparameters. And so now there's one more way we can use to improve our model's hyperparameters, and it's with grid search CV. So it's kind of similar to randomized search, but it's got one key difference. We'll have a look at that in the next video.